Hi, we are Group 404, and today we will be presenting to you our project on improving the lives of the visually impaired. So today we will be giving you a bit of an introduction and a background on who the visually impaired are, as well as the existing solutions on the market, and then finally our proposed solution. So what exactly is visual impairment? Visual impairment is the inability to correct loss of vision with glasses. The World Health Organization, known as WHO, also states that the leading cause of visual impairment is unoperated cataract. In the United States, the American Foundation for the Blind defines legal blindness as a degree of loss in which the individual has a diagnosed central visual acuity of 2200 or less with their better eye, and that is in the best possible correction and or visual field where they can see under 20 degrees. So with a quick background, there are currently 253 million people who are visually impaired. That works out to be approximately 3 in 100 people globally. 36 out of those 253 million are legally blind, and the other 217 million have mild to critical vision loss. As well, there are over 81% are over 50 years old, and 80% of the cases could have been prevented. We chose this project because the visually impaired are a small yet very important cohort of people in which computing can have a major beneficial impact on their lives. Our group is striving to provide solutions to better help these individuals integrate into society. In doing this, we are aiming to help the visually impaired with their everyday activities and decrease the challenges they face in performing these tasks. Now I will pass it along to my teammate who will explain the current solutions that exist on the market, and later they will speak about our proposed solution.
So now I'll discuss several problems faced by the visually impaired, which we are focusing on, together with some existing solutions. First, the visually impaired have problems with recognizing items, such as telling apart money or color. Current solutions are mainly apps that allow users to upload photos and obtain audible description using image recognition technology. However, the accuracy is limited since the image may be blurry or off-centered. Other apps connect visually impaired with sighted volunteers for assistance. A study has found that reading is crucial for visually impaired people to boost mental well-being and develop skills. They use Braille to read physical print. As for electronic form, there are text-to-speech translators or screen reading technology. However, there is insufficient support in terms of audio content or screen reading optimized size. Screen readers are only able to read in a linear fashion, and it's up to developers to optimize content. Sensors other than sight is less helpful in navigating to extremely distressing for the visually impaired. While GPS navigation devices are helpful outdoors, they are unreliable indoors and imprecise. Bluetooth beacons can be used with an app to guide users to specific locations, but this requires a different app for each property. For those with residual vision, smart glasses recognize objects and display the image on the lenses, but in the process losing detail. And of course, safety is a primary concern when traveling outside. Visually impaired people largely use a white cane, which can be enhanced with a smart cane to detect objects with ultrasonic ranging and convey information using vibrations. Raised tactile pavings complement white canes at dangerous junctions. While the discussed solutions are imperfect, they show the directions of current research and the gaps to be filled. These existing solutions have motivated our own idea, which will be discussed by Wayner.
For our solutions, we aim for it to be cheap, comfortable, safe, durable, convenient, and easy to use. For our first solution, we have the 5 due to the 5 features that it has. It has a lens capable of changing its focal length, an image recognition sensor to set the lens to the desired focal length with a push of a button. This allows the visually impaired to press a button for the sensor to determine the optimal focal length of the glass required to project the image at the most precise resolution. We also have a bone conduction module which is connected to the user's mobile phone that will collect information from other sources, mainly the cane and the glove, which will be elaborated in the next 2 slides. It will project these informations to the glass for the user to interpret. Also, the microphones is there to allow us to integrate the voice assistive technology by current pioneers such as Google and Apple. We also have the listening glove, which consists of an outer surface that is able to detect and read Braille, and then transmit that information to the glasses. It also has an inner surface that produces information in the form of miniaturized tubes, imitating Braille. And for the smart cane, we have an image recognition device on the cane to determine the brands and information about the item that is detecting. We also have a proximity sensor placed at the base of the cane that can detect special stickers. We also have a GPS system integrated into the cane and a smart connector to allow users to attach other compatible devices on the cane. And why it works will now be left to Siyu to discuss.
With our proposed solution, we aim to reduce the pains caused by impairment of sight, especially those related to mobility and safety. Firstly, our solution helps to increase the safety and situational awareness of the visually impaired. The image sensors on the spectacles and cane can work together to detect danger and obstacles. These can include static environmental hazards such as overhanging branches and potholes. With deeper analysis of the captured images and videos, we can also detect fast-moving objects that can pose a danger to the user, including vehicles, bicycles, and even joggers. We can then alert the user to the hazards by sending them a voice message using the bone conduction module on the spectacles, or a vibration or tactical alert using the surface haptics on the glove. The same set of functionality can be applied in many other scenarios as well. The spectacles and the cane can act as eyes for the visually impaired. The images and videos they capture will be sent to the phone for processing before any useful and relevant information is conveyed to the user via the bone conduction or surface haptics modules. Thus, we are also able to solve the issues of recognizing items, reading descriptions or longer publications, as well as navigation. Ultimately, with the help of our solution, visually impaired persons will be able to feel more confident about their safety when they're outdoors, as well as confident about their ability to navigate. Being no longer quite so hampered by their lack of sight, our solution will also allow them to live more independently. They will no longer have to depend on others for simple things like reading a short description or article, or even just determining the color, appearance, or design of an item. This will also help eliminate some of their concerns about being a hindrance to their family members, which again leads to an increased confidence level. However, we do recognize that there are some limitations to our solution. Firstly, such products may not be widely accepted by the visually impaired community. Some people may not like or may find it awkward to have so many assistive devices visible on them all the time, and this may limit the appeal of our solution. For example, Google Smart Glasses was famously rejected by the public, who coined the term glassholes to describe those who wear their smart glasses. However, with a better and more subtle design, and an understanding that our solutions are assistive devices meant to help the visually impaired, we can try to minimize the possibility of such a rejection. Also, another concern we have is that investors might have little incentive to sponsor such proposals, as the solutions are somewhat limited to visually impaired persons and may not have a far-reaching audience. Due in part to this, the products may end up being slightly costly due to the relatively small market size and the need for companies or organizations to recoup on their investments. These challenges can all be overcome, and this is where we need your help. If you are a governmental or welfare organization, we need your help in providing the financial backing that can make our solution a reality. And for everyone else, you can help spread the word. Let people know about our solutions so that they may be implemented sooner. Let us all work together to improve the lives of the visually impaired. Thank you for your attention.